a simpler way to codify your infrastructure. And I'm going to be comparing Terraform and Pulumi. As I go along during the talk, I'll be flipping between slides as well as some live demo. And feel free to ask questions during the talk or at the end of it. So why should you care about as a code model in general, right? Whether it is infrastructure as code or configuration as code? There are top 3 points which come to my mind. First, it allows you to manage your IT infrastructure or your applications with declarative definitions. What that means is you don't have to be bogged down with specifics of the API calls, what request to send, or what response to expect from it. Second, you can avoid configuration drift. You'll often hear developers say, it worked in my environment. I don't know why it's not working in theirs. This usually happens when apps are being moved from dev to QA to staging or prod environments. With as a code model, these tools are usually capable of comparing your current state of infrastructure against what you want to deploy, that is the desired state of infrastructure. So they always ensure that you are deploying the same artifacts, the same application with exact same configuration, irrespective of the environment they're deployed in. And finally, it's easy to revert the infra to a previous state. Let's say you deployed an application to your production environment and it failed for some reason. And you want to go back to the previous configuration, right? Or the previous state of the infra. Since it's as a code model, all you have to do is commit your code to a Git repository, whether it's GitHub, GitLab, Bitbucket, or anything of your choice, and just go back to the previous version and redeploy that. Usually these tools are smart enough, like I said, they can compare the state, so they can go and revert back those configurations for you. And this becomes very important, especially in a multi-cloud world where you have different cloud environments and also your on-prem environments, which might be based on your VMware data center. And in this talk, I want to focus on this specific area as to help you navigate to choose one of these tools, whether you should go with Pulumi or you should go with Terraform for managing your as a code model. But before that, a little bit about myself. My name is Shri. I'm a technical marketing architect at VMware. I focus on public cloud operations and security, and I'm part of the Cloud Health team. You can follow me on Twitter, Medium, GitHub, or LinkedIn at iShriwitz. So if you just type infrastructure as code in Google, you'll see a ton of tools out there. And I have shrunk those down to one of the most popular ones out here, which include Terraform, Puppet, Chef, Ansible, Pulumi, and CloudFormation from AWS. You'll also hear Azure Resource Manager from Azure itself. While most of these tools can do different functionalities, but there are two primary categories. One is infrastructure as code. As the name suggests, it manages infrastructure for you. And the second one is configuration as code, which is meant to help you automate the configuration of your applications. So as an example, deploying of EC2 instances is done by infrastructure as a code tools. Whereas, let's say you want to start a MySQL server or you want to start an Apache server within that EC2 instance, that's done by configuration as a code tools. So from the tools on this slide, Terraform, Pulumi, and CloudFormation fall into the infra as code category, and Ansible, Puppet, and Chef fall onto the configuration as code category. I've done a previous talk on Terraform versus Ansible, so you can go and check that out. But in this talk, I want to focus purely on infra as code. And within this domain, the two popular tools which always show up are Terraform and Pulumi. Terraform has been there for quite some time. It's a tool from HashiCorp. It's pretty well known in the industry. And Pulumi is a brand new player within this space, but gaining a lot of traction. So let's first understand what's common between these two tools. First of all, both of them offer freemium models, right? There's an open source version and there's an enterprise version. Enterprise version offers you more capabilities like RBAC, OAuth, than others. Both of these tools work with major public and private cloud providers, whether it's AWS, Azure, Google, VMware, Oracle, or others. And that's different from CloudFormation from Amazon or Azure Resource Manager from Microsoft, which is specifically meant only for their domains, right? And both the tools offer a client-only architecture, so you're not maintaining any kind of additional servers to run all of this infrastructure like you would have to do in case of Chef or Puppet. and they're immutable in nature. So what that means is if you make a modification to the code or the template written either in Pulumi or Terraform, they will result in recreation or deletion of the resources. So let's say you spun up a EC2 instance which has 4 gigs of RAM, and now you want to change it to 8 gigs. It'll create an 8 gig RAM EC2 instance and it'll delete the previous one. And finally, both of them offer CLI. If you're someone like me who uses CLI for your day-to-day work, that's a very good option with both of this, and they offer for all the major operating systems out there. So what are the differentiators, right? We saw what are the common things. Let's start with Terraform. Terraform offers a declarative code model, like any as a code tool does. So in this, you basically define the desired state. So you tell it what state you want your AWS or Azure or VMware infrastructure to be in. And then Terraform will figure out the exact deployment workflow, right? It'll figure out in what order should I deploy these resources. For example, if you want to create an EC2 instance on AWS, you first need a VPC, then you have to create a subnet, and then you have to create a security group and attach the EC2 instance, right? But within a Terraform template, I'll show you in a bit when we do the demo, you can arrange them in any order. Doesn't matter, Terraform knows the exact flow in which these resources should be created. And the way you do that is by using HashiCorp language. It's a proprietary language from Terraform, from HashiCorp, which you use to deploy across different resources. And second is, how do you manage state? So basically, how do you know what is happening when Terraform deploys, right? And that is done in Terraform by using a TF state file, that is Terraform state file. And that is used to store the state of the infrastructure post deployment. So next time if you make a modification, let's say in the first instance, you created 5 EC2 instances, and now you want to create 10. Terraform will look at your previous TF state file, and it will take a difference, and that would be 10 minus 5. So it would add 5 additional instances to your environment instead of creating 10 brand new, right? And where do you store this, right? That's an obvious question. So you can store it either locally on your laptop, which is not recommended for production environments, or you can store it on S3 or Azure Blob, which are like persistent stores, but you will have to manage the lifecycle of the buckets themselves. Or you can use a fully managed service from Terraform, which was recently announced. It's called Terraform Cloud. This is a service which is again available as a freemium model. There's a free version which is I think up to 5 users. It's free, but after that you might have to get the paid version. But that allows you, to be carefree about the state management or the management of the files themselves. And here is a sample Terraform code down here, right? So I'm trying to create an S3 bucket. I just say resource, what's the type, AWS S3 bucket. I give it a logical name, VMware code bucket. I'm going to use this as a reference within my template if I want to refer to this resource anytime in the future. And then I give the actual name of the bucket. It says VMware code Terraform bucket, right? And I can add additional tags if I want to. So let's look at the code itself, how it looks. So here I'm within VS Code. You can see here on the left side, I have my Terraform files. There are a few files over here. I'll go through them. The first one is provider.tf. And this file basically talks about, gives you information about your cloud provider. So I'm saying my provider would be AWS. That's what I want to deploy. I want the access key and secret key, and I'm telling it the region I want it to deploy to. That's US East 1. And I can ask, if I use var, that's variable, I can ask the user to input the access key and secret key at runtime, right? And you define variables within variables.tf file mentioned over here. This file is very useful if you're doing, let's say, EC2 deployments, right? And you want to add different AMIs, but you don't want to hard code them. So variables.tf is the right place to do that. Right? You can define all of your variables over here. And then finally, you have demo.tf, which is my actual Terraform file in which I have created the resource itself, which I showed you in sample, right? Resource AWS S3 bucket. And I want to create a bucket called as VMware code Terraform bucket 123, right? So let's see how this looks from CLI, right? So I'm here. All I'm going to do is I'm going to say Terraform apply. And then Terraform should go and calculate what are the different resources it needs to create. And in our case, it's simple. It's just an S3 bucket. So you'll see here, it says it plans on adding one resource, which is an S3 bucket with all of this configuration, right? So if I come back here, if I go to my S3 console and just refresh, you'll see that we don't have a VMware code Terraform bucket yet, but I'm going to say yes. And then now it'll start deploying, right? And as soon as it's created, it'll let you know that the bucket was created, and it'll also populate the information in a TF state file. So you see here, it says resource completed. And now if I clear this and I see there's a terraform.tf state file. And this file contains the state information. So if I go to AWS dashboard, refresh it, there you go. You have the bucket, right? And that's as simple as that. And if I want to delete this resource, I can just say terraform destroy. And obviously they have a switch within the CLI. It's called auto approve. So I don't have to type yes like I did in the previous case when I was applying. And this is useful if you want to integrate within your CI/CD pipeline, right? You don't want manual interruptions over there. And once this executes, it says, one resource has been destroyed. If I come in here and if I refresh, that bucket is gone. So it's as simple as that with Terraform, right? Now let's look at Pulumi. So what are differentiators over here? With Pulumi, you can use a programming language of your choice to actually write the script. So let's say you already know Python or Go, TypeScript or JavaScript. You can start writing using these languages, right? You don't have to learn a new language like you would have to in case of Terraform, right? So, excuse me, there's no YAML or HCL or any of these formats going on over here. And how do you manage state? Again, Pulumi offers similar options. You can use a fully managed service from Pulumi. It's called Pulumi Service Backend. Or you can store it locally or on S3 or using an Azure blob storage, which obviously you have to manage. And here is a sample Pulumi code, right? I've written this in Python. It says import Pulumi, I import the package, and then I create a bucket over here. It says bucket, S3 bucket, and I'm providing it a logical name like we did in case of Terraform. It's called VMware code Pulumi bucket. And then I'm providing the actual name of the bucket itself, right? That is the physical resource which will be created in AWS environment. It's very important to note in case of Pulumi why we do this, because Pulumi has a concept called as auto naming, in which it'll automatically append an additional string to the name of your logical resource and then deploy it to AWS, right, or Azure. And why does Pulumi do that? Let's say all of your developers are writing using Pulumi, and everyone wants to call their bucket my dev bucket, right? And as we know, in AWS, it's not allowed. S3, the bucket names have to be globally unique. So Pulumi will append an additional string, but for the developers themselves, they can just keep referring to the logical name, right? For them, it would be my dev bucket, but on AWS, it might be my dev bucket 123. And the developers don't have to worry about that. Pulumi does all of the management. But if you don't want auto naming to be enabled, then you have to use this option, where it's bucket equals some specific name. Let's look at the demo. Right? So I can close this. I'm going to open my main file. Right? And you can see here, I'm saying S3 bucket. Let's try removing this option, right? And I'm just going to keep it. I'm just going to call VMware code bucket, right? And you'll see there are two other files over here. There's one pulumi.yaml, which is basically the configuration file, which I can use for Pulumi for this particular project. The project is demo power session, right? And I'm using runtime as Python and my virtual environment. And then you can create specific stacks within them, right? My stack can be one particular kind of infrastructure that I want to deploy. In my case, I'm deploying an S3 resource, and I'm providing the configuration parameters that would be needed to go along with that. And that's about it. So let me switch to the terminal. I'm going to go to my Pulumi samples directory and demo power session. And all I have to do is I have to say Pulumi up. right? And before I do that, I want to show you the backend service, right? The fully managed service. This is the fully managed service from Pulumi, which you get, which has both free and as well as paid versions. And I can see here that my project already shows up. Right? I had updated 18 hours ago. Now, once I run this script, you'll see that the entire state would be copied over to this platform automatically, right? So I can say Pulumi up. So now it shows that it's trying to create resources, but you'll see here it says it wants to create 2 resources. And I can go here and click on details, and you'll see it wants to create a stack, which is a Pulumi concept, and then it wants to create an S3 bucket. And you'll see a number here, URN, it's called Uniform Resource Number, and that's the identifier Pulumi actually uses to differentiate similarly named logical resources, right? Now, if I say yes and I deploy, remember, the name of our bucket was VMware Code Bucket 1. Now, if I come in here, it's creating the resource for me. It says created. Let's go to our AWS console and refresh. You'll see that it has created the bucket, but the bucket name is VMware Code Bucket 1, and it has a randomly generated string. So that is the auto-naming concept I was referring to earlier. And similarly, in Pulumi, I can say Pulumi destroy, which will go ahead and destroy this resource for me. And if I don't want the auto-naming, I can change it. I can come in here and I can say bucket equals. I'm just going to copy this exact name because that's what I want the bucket to be named. And this might be useful if you're doing static deployments. If you want to create a static website using S3, that's where you don't want auto-naming probably enabled. I'm again saying Pulumi up. It says it wants to create 2 resources. That's fine. I'm going to allow it. And now it's going to go deploy and create VMware Code Bucket 1. See, now the random string which was appended to this doesn't exist. And if I go to the Pulumi dashboard, just refresh this page, you'll see that the information about my stack was updated. It says VMware Code Bucket 1 was created a few seconds ago, and I can see the region, and I can see the GitHub owner and what kind of project description I had before. So now we have that, which one to use? The famous words ever said, it depends. So it depends on what use case you're trying to solve. And I've just put together a few of them for here to refer to. Let's say you're already familiar with the programming language like Python or Go, JavaScript or TypeScript. You can probably start using Pulumi, right? The major advantage over here is, first of all, you don't have to learn a new language, but you can also use constructs like for loops, while loops, if else kind of conditions. You can do that in Terraform, but by using count as a variable and asking user to input either 0 or 1, but it's not that elegant, right? But let's say you're not from a programming background, but you want to automate things and you're aware of automation workflows. And that's where Terraform would be useful. You don't have to learn a full-fledged programming language. You just have to learn few concepts of HCL. And obviously, if you can avoid compiling of the code itself, right? Let's say you're using Golang. With Pulumi, you actually have to build the package and then use Pulumi up as a command. So you do have to know some constructs of the programming language itself. If you're looking for community support, I think Terraform clearly stands out there. It has a very robust and healthy community of contributors. Not to say that Pulumi doesn't have, but Pulumi is a new player and it's trying to build community around that, and they're very open to contributions from outside players as well. And what about the scenario if you already have existing automation assets, right? Let's say you started with Terraform because they were the first player in the space, but now you're thinking of migrating to something else. That's where Pulumi can come in, right? Pulumi offers a free open source tool. It's called TF to Pulumi, which is Terraform to Pulumi, which can basically consume your existing Terraform state files and convert them to Pulumi format, right? So that allows you to create a bridge for using from migrating from Terraform to Pulumi if you choose that way. And finally, does this mean that since you use infrastructure as a code, you use automation tools which can do sophisticated workflows, it's cost effective and secure? Simple answer is no. While they are developing some tools to help you manage policies, there's a project from Pulumi, it's called CrossGuard, and there's a tool from Terraform called cost estimate feature, which allows you to estimate cost in, gives you point in time at the time of deployment cost. But they don't actually cover the breadth. And the reason is, let's say you already have resources, brownfield scenario, you already have resources deployed within your environment. And now you deploy a new set of apps or infrastructure, the security has to be taken into consideration, including all the apps and infrastructure within your environment. It can't be siloed, right? And the same goes with cost optimization as well. And that's where VMware could help you, right? We have a tool called as Cloud Health that can optimize cost across multi-cloud and hybrid cloud environments, and also secure your multi-cloud environments with real-time alerting. So we can look at, let's say, hey, Shri created an S3 bucket just now, and he's made it publicly available, right? Or he has not enabled encryption. And it can do more sophisticated alerting across different resources within your cloud environments, and also help you optimize cost by suggesting you or recommending you based on your usage, whether you should downgrade from, let's say, an extra large instance to probably a medium instance to save cost and maintain the same consistent performance. And we do provide API supports for you to integrate with your other developer tools. If you want to integrate with your CI/CD pipelines, you can write simple Python scripts, as you would do with your Terraform or Pulumi scripts within your pipeline. It would be the same exact way with these APIs as well. Here's a quick look at our multi-cloud cost optimization dashboard. You can look at all the different resources which are being consumed within your environment. You can compare their costs, and customize the reports as per your needs. And also, you can look at your security and compliance. If you are adhering by different compliance standards like PCI, HIPAA, GDPR, or others, right? So it can give you a holistic view of what is happening within your environment. So, combining a Terraform or Pulumi-like tool along with an cost optimization and security tool could be a good strategy for you to monitor and ensure that all of these environments are secure. That's all for today. Thank you, everyone. You can join me. You can follow me on LinkedIn, Twitter, or GitHub at iShrivats. And if you have any questions, do let me know. Thank you. Thanks for joining.